Shocking, though. Let me call Peterson a loser. Okay.
Come on.
Okay, counting outcomes. So far, the one way we've counted outcomes for multiple events is to make a tree diagram. This section gives us 3 more ways we can count outcomes of multiple events happening. We'll probably get through 1 or 2 of them today. And the first one we're going to talk about, let's see, tree diagram. Today we're going to do the fundamental counting principle. And we're going to get into permutations and combinations. Fundamental, permutations, and combinations. Tree diagrams are very limited because if you've got a lot of outcomes, it's very difficult to make a tree diagram. There are a lot of events with a lot of different outcomes in them. Okay, let's go with the fundamental counting principle first. And you had all of this stuff in advanced algebra. It'll come back. Fundamental counting principle says if event 1 has m outcomes, event 2 has n outcomes, then event 1 followed by event 2 has do you remember? How do I get the total number of outcomes if I know how many are in each event? You multiply. It's an AND situation. M times n outcomes. So let's look at a few that we've drawn tree diagrams for and show how we could use the fundamental counting principle to come up with that same number. So our first example is going to be things we've seen before. So we're going to find the number of outcomes for and I first want to go back to our rolling 2 dice. That's 2 events. What do we know that outcome was when you see the tree diagram in your head? How many outcomes did it have on the far side? It had 36 outcomes because we had 6 branches, and then off of each of those there were 6 branches. Well, the way the fundamental counting principle works is I'm doing 2 events. Event 1 and event 2. I like to make little dashes. Event 1 is rolling a die. How many outcomes are there for rolling a die? 6. Second event I'm doing is going to roll a die again. How many outcomes are there? 6. If I multiply, that's where the 36 is coming from. Then we looked at, I think we flipped 3 coins. Flip 3 coins. How many events am I doing? 3, so I need 3 dashes. Each dash represents an event. So how many outcomes are there for my first event if I'm flipping a coin? 2. The second one? 2. The third one? 2. For a total of how many outcomes if I was to draw the tree diagram? 8. See how the fundamental counting principle is working? Okay, let's change it up a bit. Let's do some examples where we would not want to draw a tree diagram for. Oh, let's see. These are in the book. Oh, looks like we are making license plates. Going to jail, going to prison. Don't get out till you make all your license plates. I don't know. That's always the big joke, though. Make license plates in prison. I have no idea. Make license plates. I don't think I spelled that right.
I think it's just CE.
No S in here?
I don't think so.
L-I-C, lice? I guess lice is spelled. I don't know. But lice, the lice that's in your hair is L-I-C. License? I don't know. Okay. The new license plates. I've got one that has 3 letters, 4 digits. That we've got going on right now, most of them, the free ones, 3 letters, then 4 digits.
L-I-C-E-N-S-E.
L-I-C-E-N-S-E. Well, see, I'm right now. I just had to think on that. Lice, just like the bumps in your hair. So did I. That's why I wrote it. Okay, how many license plates do you have to make before you get out of prison? Okay, how many events are in this? Each time you do something as an event, each time you have a choice is an event. How many events does it take to make a license plate? 7 things. I got 7 slots to fill in. I got to pick a letter, pick a letter, pick a letter, pick a number, pick a number, pick a number, pick a number. So 7 events. Okay, event 1 is to pick a letter. How many choices do I have? 26 letters in our alphabet. Second one, digits. 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 options. Digits, digits. What do I do with all of those numbers? Multiply. It's going to be very big. We're not going to take the time to actually multiply. It's coming. We couldn't do an NPR or NCR in this one. That wouldn't be possible.
175 million.
175 million. That's a lot of license plates. Figure out how many per day, how long it's going to take to get out of prison. We can make a great problem out of that.
So are we doing the tree diagram by reading?
We are not doing the tree diagram. That would take us a while. Okay, if I'm not allowed to repeat any letters or digits, that'll shorten my sentence time a little bit. It would. So what do I got for my first event? 26 options. My second event? 25, 24, 10, 9, 8, 7, 6. Okay, I guess I want to do a challenging one in here. This will confuse you.
Really?
This is tough. I would not expect anybody in here to come up with this one on their own.
So why would you?
Oh, well, because we're gonna do it. Yeah.
It won't be on.
Oh, it might be. A little extra credit style, maybe. It's not bad. So, we just did no repeats, okay? And we have this number here. What is, I guess I need this number. What is this number? I guess I kind of want to have that total. It'd be easier to talk about.
78,624,000.
No. What is it?
78,624,000.
78,624,000. So, how many plates have the word God? That's the question.
Oh,
Is it just one license plate that I make that has the word God?
no.
No,
No.
because all the numbers would be different.
All the numbers could be different at the end. Oh, you're on the right track. Let's see the ones that... So I want to eliminate all of the license plates that have this happening. Okay? Which means I would have had one choice here, one choice here, one choice here. Came up with God. But what could happen over here? 10 times 9 times 8 times, because of no repeats. So all of these license plates would have the word God. So how many is that? You just multiply. This is just 1 times 1 times 1 times 1.
5,040.
What is it?
5,040.
5,014?
40.
40. So, how many plates would I have total then without the word God? What do I have to do? 5,040. I can listen. 5,040. So how would I get the total number of license plates if I'm not allowed with the word God? Yes, find the total number of license plates and subtract off those. Yeah, a lot of times on it, because I think there might be one like this on a test, people will subtract 1, because they think there's one time God comes up, but it's all these different numbers over here that you can have too. So all of those license plates have the word God on them. Okay, good job. Move into permutations. Well, I better, we've got 15 minutes left? I'll stop. We'll stop.
Oh.
I lost the worksheet.
Let's see. What can I give you? Oh, yeah. We've got 15 minutes left. I'll do a little bit. I wish I had a few from yesterday because we had issues with them. I think you can do 5 through 14. Page 140.